Hello class, Mr. Kablan again, and I'm here to present the third and final lesson here for Chapter 8, dealing with quadratic relations, specifically with another type of form. And we're also going to revisit how to find the zeros after we factor out a quadratic relation. Now you can see here when we're looking at the quadratic relation, our third form that we're going to look at, okay, is actually going to be a type of form where you have only two terms. Okay, notice that what we have here is y equals ax squared plus c. So we only have the x squared term, okay, and a c term, which is the number on its own. Now, again, notice that this particular equation, okay, has obviously an x and a y, but also notice it also has an a and a c. Now, the a and the c that we've seen in the previous chapters are exactly the same thing as this form as well. So starting off with the c, okay, remember that the C represents the y-intercept, or where the curve touches the y-axis. Okay, and remember that the A determines whether something has a minimum or maximum value, and that was determined from the fact that if you're looking at then A that is positive, it's a parabola that opens up and you have a minimum. Okay, and when the A is negative, you have a parabola that opens down and is a maximum. All right, so a couple of things that, again, just a quick reminder when you're looking at the different forms that if they have the same letter, okay, they represent the same thing. All right, so today here, what we want to do here again is to find the minimum or maximum. And in this case over here, we're going to approach it the exact same way that we did in the previous lesson by first identifying the A value. Okay, and then from there, the A value tells us which direction it goes, opens up or opens down. Okay, and from there, we can determine the minimum or maximum, and we're also going to look at how we can find its value. All right, so what we have here in the chart, as you can see, are three different types of relations, and we're going to break it down according to what we saw in the previous slide with dealing with the A and the C. So I've broken it down so you can see exactly where to look when you're given an equation here. So start off with the first one over here. We have here a value here of 5. So since the 5 here is positive, okay, this tells us that the parabola opens upwards. And remember that when the parabola opens upwards, okay, what you have there will be a minimum value, okay, and in this case here it's 0. Now you're probably wondering, well, how do we find the minimum value? Now remember the minimum value, okay, is where this parabola, okay, it's the y-coordinate of the vertex. That was from chapter 6 there. But a quick way to look at it is to look at the c value when you have this form here, okay? So just to let you know how to find it here, okay? So we next one here, we have y equals x squared minus 16. So if you look at the a value, okay, we have that invisible one that loves to hide everywhere. So just like the previous example, what we have here is a positive a. So this tells us the parabola also opens upwards. Now for this one here, we do have a minimum, but this one here has a value. So as I said before, the value you can find just by looking at the y-intercept here. In this case here, the value here is negative 16. All right. And last but not least here, for the a value for this one, okay, notice we have a negative a value. So since the a is negative, what you have here is a parabola, okay, that opens downwards, okay? And remember, when something opens downwards and you're looking to determine whether it's a maximum or minimum, okay, think about the very top. The top always represents the maximum there. So what we would have here would be a maximum value, and in this case here, the maximum value here would be the 27. All right. So that's just looking at the equations and determining the direction as well as the actual minimum or maximum value. All right, so just as a quick little exercise there, so let's get into some calculations here. So what we're going to do for today, we're now going to look at another type of factoring that we saw in chapter 7, dealing with the difference of squares here. So remember that when you're solving for the zeros, what we have to do here is to let y equal 0 and solve for x. So we're going to do that in this first step for this particular question here, all right? Now remember that anytime you have two terms separated by a minus sign, where one of the terms happens to be an x squared term, okay, and the other one happens to be a number, okay, what we have to do here is perform the difference of squares here, all right? Now remember, with a difference of squares, there was a special way to set up the brackets here, where you would have two brackets, where the first bracket would have a plus in the middle, and the second bracket would have a negative in the middle. Now keep in mind that you always set this up automatically only for a difference of squares. Now, remember with the difference of squares, the easiest way to do this is to take both the x squared and the 25 here and take the square root of each one. So remember that all you have to do here is take the square root of x squared, gives me the x, goes in the first spot. Okay, take the square root of 25, and that'll give me 5, and that goes in the second spot. Okay, so that gives us now the equation in factored form after we factored it using a difference of squares. Now, to solve for the zeros, all we're going to do now, and then we saw this in the last lesson, is to break apart each bracket and then solve for each bracket by letting it equal 0. So this here would be the first 0. So I'm going to put 0 equals x plus 5. So all we need to do is leave the x where it is, take the positive 5, move it to the other side, and then it becomes a negative 5. Okay, same thing with the next one here. This will be our second 0. So we take the x minus 5 bracket, we let that equal 0. Now this time you're going to take the negative 5, move it to the other side, and it gives me positive 5. All right. So notice solving for the zeros is exactly the same steps as we did in the last lesson. Only difference in this one, we're just revisiting how to factor using a difference of squares. All right, let's take a look at another example here. Okay, same thing. We have x squared minus 16. Okay, let the y equal 0. Okay, and remember this is a difference of squares. So you're going to set it up by putting two brackets with the first one with a plus sign, second one with a minus sign. Okay, and again, next step, take the square root of each term there. So we take the square root of x squared, gives us x, goes in the first spot, and the square root of 16, which gives us second spot there. All right. And that's pretty much in terms of revisiting how to factor a difference of squares here. So remember, now we need to solve for the zeros by breaking apart each bracket, okay, and letting it equal 0. So for the first 0, we're going to take the x plus 4, let that equal 0. Now remember, you always leave the x where it is, and you just move the number. So we take the 4, move it to the other side, and make it a negative. All right. Okay, next part here, we take the second 0. Okay, we let that equal 0. Take the negative 4 in this case, move it to the other side, becomes positive. All right. Again, same techniques, just different numbers. All right, let's proceed over here. So now what we want to do here is use a little bit of algebra to figure out the equation of a quadratic relation. So this is a new topic to you. Now, just to talk about what we're going to do here, it's very similar to how we found the equation of a line back all the way in chapter 3. The only difference in this case is we're dealing with a quadratic relation here. So again, the way you do this, again, is just to read the question very carefully, see what information is given to you, and see where that information goes into the equation that's given to you. So the graph of the quadratic relation y equals ax squared plus 5 passes through the point 2 and 21. So what we want to do here is to find the value of a and take that value of a to come up with the equation for this quadratic relation. All right? So first thing we want to do is we're going to take our equation of y equals ax squared plus 5. And what we want to do here is, since we were given a point, remember that each point or ordered pair is always expressed in terms of x and y, when the first number is always the x, and the second number is always the y. So this x is going, this 2 is going to go in where the x is, and this 21 is going to go in where the y is. All right. Now you're going to see in the next step when I replace the 2 in for the x, don't forget to put brackets around it. All right. Now pay very close attention to this next step here, because this is the step that people have a hard time understanding in terms of why it happens this way. Okay, remember that what you want to do here is to simplify everything before you start solving for the letters. So I want you to take a look at the 2 squared over here, because we're going to square that. Now, when I square the 2, okay, 2 squared will give me 4. Now, notice the 2 squared, okay, is attached to the a. When you evaluate the 2 squared and it gives you 4, remember the number always goes in front of the letter. So the next line is going to look something like this. All right. So when you get to this step, don't forget that when you simplify it, the number is always in front of the letter. Okay. Remember, that's why it's called a coefficient. Okay. All right. The next thing we want to do here is we want to solve for the a. So what I'm going to do over here is I'm going to put a blue box around the 4a over here, just to remind ourselves that we need to leave that alone until we absolutely need to deal with it. So since the 4a is going to stay where it is, we have to take care of everything else that's around it. So the first thing we need to do here is take the 5, okay, move it to the other side, and subtract it from the 21. So what we have there will be 21 minus 5, which gives me 16. All right. And the last step here to solve for a, remember we have to divide both sides by the coefficient, which is the number attached to the letter in this case. So for the final step, we need to divide both sides here by 4. Okay, and then 16 divided by 4 will give me 4. Okay, so the math behind this, believe it or not, we're pretty much done, but we haven't fully answered the question yet because we still need to come up with the equation. So to come up with the equation over here, okay, what we have to do here is to take the y equals ax squared plus 5 and just simply replace the a there with a 4. So the equation for this particular question is going to be y equals 4x squared plus 5. All right. So again, make sure that when you get a question like this, and you're going to see in your package there, okay, always take a look at what pieces of information are given to you. Just remember that anytime you're given a point or an ordered pair, the first number is always x and the second number is always y. Okay, and in most cases you'll be asked to solve for the a, and in some cases you'll be asked to solve for the c. So it's very important again you take that point and understand the point is always going to replace x and y. All right, so last word problem we're going to look at a golf ball here. So you should know that any object, it doesn't matter what type of ball it is. Okay, so we saw an example of a soccer ball in a previous lesson. Okay, again, laws of gravity, anything that goes up must come down. So we have to factor that in as we look at this particular example. Okay, so Cheetah hits a golf ball from the top of a mountain, and the path of the ball can be represented by the relation h equals negative 5t squared plus 245. Okay, and the two letters that we have here are h and t. H represents the height of the ball, and T represents time in seconds. All right. So what I want you to picture here is I want you to picture you being the golfer here. Okay. So try just to imagine that. Okay. And for this question here, it says, from what height was the ball hit from? Now I'm going to present this two ways here, and then once I present the two ways, I want to show you why it's important to know the two ways. And the first method, we can actually figure out the answer just by looking at the equation. So the way we do that is we just look at the y-intercept, okay? And remember, the y-intercept is just the number that's on its own here. So you can see just by looking at the equation, okay, the answer for this would be 245, okay? Now, I must warn you that you can only use this method, okay, when it's in this specific form here, all right? Now, the next method I'm going to show you, okay, is going to come in very, very handy when you get into more complicated examples where the form might not always be like this, okay? Now, if you think about this for a moment, okay, when you're hitting an object or throwing an object, okay, when it comes to height and time, okay, basically what happens here is that once an object is released or thrown, okay, time starts going. So the way you approach this question over here is that you need to solve for the height of the ball before it was hit. Because again, once an object is hit or thrown, time starts moving. So what we need to do for this is we need to let time equal 0, okay, and then solve for the h. Now, like I said, this comes in as a very handy solution over here because you can do this for any type of quadratic problem, regardless of what form it's in. Now, the reason why we do this again is in this particular question, okay, this golf player is hitting a ball from something that's from some height, okay, but we can find that height simply by figuring out what height it is at time 0 because the ball has not been hit yet. And you can see that when we do it that way, okay, we wind up getting the same answer. Now, like I said, okay, the first method you can only use when you have it in this form, okay, and once you see more complicated forms in different courses, it's not going to work, okay? Heads up for grade 11. Okay, but in order for method number 2, as long as you understand that to find out the height of an object before it's been hit or thrown, you just need to let time equal 0. Okay, so just keep that in mind there. All right. All right. Next one's going to be a little bit hard to grasp at first, but what you, again, just if you think, just think about the object for a moment. Okay, in this question here, it says, how many seconds was the ball in the air before hitting the ground? All right, so remember there are two letters here, H and T, and we need to know something about an object that hits the ground. So remember that every object that goes up must come down. Okay, so you have to ask yourself, when the object touches the ground, how high is that object off the ground? Well, if it's on the ground, okay, it's not going to have any type of height. So guess what? In order for you to solve the time, okay, for when an object hits the ground, okay, what you have to do here is you need to let h equal 0. Okay, now pay very close attention to the sequence of steps because it is very, very critical. Okay, always start off by writing the formula first, or the quadratic relation. Now, you know what's the very first step here I'm going to do is take the h over here and then replace it in for the 0. Okay, so this just represents that we want to find out what time the ball landed on the ground after it was hit. Okay, so remember that when the ball touches the ground, okay, it's going to have a height of 0 because it's not, there's no height. Okay, it's on the ground. All right, so what we want to do here, Okay, remember that since we're solving for the letter t, okay, we need to leave the t alone until the final step. So I'm going to put a blue box around it. Okay, and you notice I put a box not just around the t, but also the -5 because the -5 is attached to it there. All right, so we're going to leave that alone until we actually have to deal with it. All right, so next thing we want to do here, we're going to take the 245, move it to the other side, and become subtraction. Now for the next step here, we need to isolate the t squared term first. So notice the -5 and the t squared are grouped together by multiplication. So the next step that we have to do here is we need to divide both sides here by -5 to cancel them out. Now again, just a reminder on the left side here, when you have two negatives, okay, that becomes a positive. Okay, so when we do that, that'll give us 49. Now, if you recall, to go from t squared to t, what we have to do here is to take the square root of both sides, okay, mathematically. But in your calculator, what you're going to do here is just take the square root of 49, okay? And last but not least, that will give us the answer here of 7. Okay, so after the ball after the ball is hit, it goes up, and it takes 7 seconds until it hits the ground. All right, so you might want to just put a star beside this example because this example is pretty hard to grasp at first. Okay, but there are many questions that you will see in the in your booklet there that's going to give you practice for these type of questions. All right, so if we take a quick glance here, I'm just going to summarize the forms that we looked at in this chapter, and what we have here are the 3 forms that we looked at. So remember that when you have all 3 terms, an ax squared term, an x term, and a c term all together, this was called the standard form. Okay. And remember that we can go from standard form, okay, to factored form, okay, by factoring. Okay, so the types of factoring that we looked at, okay, so the common factoring, difference of squares, and product and sum, okay, you can do that using in standard form there, all right. The difference of squares specifically, okay, deals with the fact that you are going from this form over here, okay, from y equals ax squared plus c to this, okay, so that would be the difference of squares, and I'm just going to write that here. Just again, you might want to make a note of this as well. So difference of squares, okay, so that's the type of factoring that we have, okay, and for this one over here to go from standard form, okay, to factored form, okay, you do what I call just as a product and sum there, all right. Okay, so that I just want to show you again the different forms and how you can go from one form to the other. Now, going back to factored form over here, and this is what we did this in the previous chapter. You're probably, well, how can we go from standard form, okay, and this form over here into, how can we can go from standard form and the form on the right side here to factored form, but how come we can't go from factored form to these two? Well, actually, we can. Okay, back in the first lesson in the previous chapter, we actually did that when we took a look at FOIL. So remember that when you have something that has 2 brackets, okay, remember you perform FOIL and you would get, okay, one of these 2 forms that you see here. Okay, so in both cases, okay, what you would have to do there is to expand. Okay, and remember we used FOIL to do all of that. Okay, so this little chart I know is something that I just came up on the spot here, but again, it's an explanation how you can go from one form to the other over here. So when you're looking at a quadratic, okay, the top 2 over here, remember that you can go into factored form by performing the different types of factoring which I've listed here. Okay, and remember that when you're factoring, okay, based on the form, you should always those are the methods that you use here. Now, one step behind over here, the first type of factoring you should always do, okay, is common factoring. So, for example, okay, I'm just going to expand on this. Sorry, I'm just going to expand on this part over here. Okay, if you have a quadratic, okay, and if the a, okay, is a number, okay, that is greater than one. Okay, so for example, if you have a 2, a 3, a 4, a 5, or a -2, -3, -4, -5, okay, you should always common factor. So basically, you common factor, okay, when a is not equal to 1. Okay, and the reason for that is because when you common factor, okay, you're going to see that you can simplify the expression after you divide each term by the common factor. Now, just a little bit heads up, I'm thinking about the course ahead in grade 11. Okay, what you see on the screen here in terms of different types of factoring, in this course, we did it only one by one separately. And the reason why I'm mentioning that because you will see in grade 11 that you will be introduced to this again. The only difference is that you will be seeing questions where you will be combining two different types of factoring. Okay, so that's why it's important to understand to know what type of factoring to do into what types of quadratics that are presented to you. All right, so that wraps up this chapter here for chapter 8. In fact, not only does it wrap up chapter 8, okay, but it also wraps up the topic of quadratics. So we will proceed to the next chapter that's going to be dealing specifically with triangles. All right. So until then, Mr. Kaplan signing off.